Let's go ahead and get started. We're going to talk about Introduction to Thermochemical Equations today as the second part to Chapter 17, Section 2. At the end of this video, we're going to continue talking about calculating enthalpy change in chemical reactions. We're also going to get a touch into using Hess's law to calculate chemical reactions net heat. We're not going to finish it, we're going to briefly touch on it today. So let's go ahead and get started. Let's review a little bit. What is enthalpy and how do we measure it? Well, enthalpy, like we said in the last video, is heat flow, and some chemical reactions and physical processes release energy into the surroundings. And when they release energy in an endothermic reaction, actually exothermic, when they release energy in an exothermic reaction, we can measure it using a device called a calorimeter, and that calorimeter measures the enthalpy change, or the energy that is released or taken in by a system. So I usually have this question: how do I express enthalpy change information in a simple way? And the answer to that question is thermochemical equations. And thermochemical equations help us to give information about enthalpy changes in a chemical reaction. What are thermochemical equations? They're chemical equations represented with enthalpy change. And the enthalpy change that we calculate using the equation Q equals mc delta T is what we call heat of reaction. And the heat of reaction is the enthalpy change for a chemical reaction exactly how it's written. What do we mean by that? What I mean is, either in an endothermic process we have heat taken in, so heat would be a reactant, and it's used to make a product, and when that happens you have an enthalpy change, or delta H, that is positive, and we would write in next to the reaction, next to the chemical equation. If you have an exothermic reaction and your heat is a product, heat is released, so heat would be a product in an exothermic reaction, your enthalpy change, or delta H, would be written as a negative number next to the equation. So we have two ways to write endothermic and exothermic reactions, either with a positive or a negative delta H, depending on the type of reaction. There's a lot of information that a delta H can give us, depending on its sign and depending on the number. In an actual example, it would look something like this, where you have solid water, ice, turning into liquid water, and that reaction involves a endothermic reaction of taking in 6.01 kilojoules of energy. And so you would write a delta H next to the chemical equation for that physical process of turning ice into water, or liquid water. Your more complicated example would be as follows, where you have two reactions here, and then a reaction that is sort of the summation when you add the two together, and then you get a new delta H of the net summation reaction over here. You don't know how to do this right now, but this has to deal with Hess's law. And we're going to deal with Hess's law in the chapter 17, section 4. So, but this is your introduction. So we were able to continue to calculate enthalpy change and talk about how it's expressed in thermochemical equations. And we got a taste for Hess's law and how we use thermochemical equations in Hess's law. If you have any questions, please let me know. Other than that, have a great night.